Hey guys, this is Madan for Cgtuts Plus, and today in this tutorial we'll be seeing on how to create a realistic looking campfire using FumeFX and Thinking Particles. We'll be using FumeFX for our smoke simulations, and we'll be using Thinking Particles for creating some nice looking ember particles that arise from the logs. Without much delay, let's get started. Here I have a basic scene with just some cylinders that are positioned so that they look like logs lying on the ground, and these are going to emit the flames that are going to come from the campfire. So first up, let's go uh, to the FumeFX rollout and create a FumeFX grid like that, and let's position this so that it's in the center of the logs, and you can see over here that I have left a bit of headroom over here on the right hand side. That's just because for the FumeFX simulation, that is the campfire, to look realistic, I'm going to add a wind uh, force, and the wind force is going to push the smoke and flames onto the right hand side. So to prevent the smoke from getting clipped due to the bounding box, I'm just leaving a bit of headroom over here on the right hand side so that the smoke doesn't get clipped off. We'll just position it just a bit to the left, and now I'm going to add a object source. Let's go into the FumeFX helper rollout and create an object source like that, and we'll add all the 4 cylinders into the object source like that, and let me tweak some of the settings in the object source. I'm going to set the temperature a bit higher from 300 to 800 because a value of 300 doesn't excite the fumes and flames so much, so it just stays on the ground. A higher value will excite the flames a bit higher so that they rise away from the ground into the skies. So let's set a value of 800 for temperature, and I'm going to set the smoke amount to 0 because in a campfire the smoke does not get generated from the logs. Instead it gets generated from the dying out flames. We'll be simulating that type of effect in this simulation. So I'm going to set the amount of smoke to 0, and I'm going to set the object's velocity uh, to about 0.5 because I don't want the flames to just be pushed out from the logs. Instead, I want them to gracefully rise up into the skies. So a value of 0.5 would do good, and the turbulence values looks good too. Now let's add the object source into the FumeFX simulation. We'll go into the uh, FumeFX simulation dialog, and let's go into the object source panel and add the object source like that, and you can see that the FumeFX dialog is not fitting correctly inside the screen, so I'm just going to elongate it, and I'll just show you which part I'm going to modify in the screen. So right now let's go into the simulation dialog, and first we are going to do some pre-visualization. For that we need some faster simulations because we don't want the simulation to slow down the computer, so that we can do some high speed simulations. For that I'm going to reduce the maximum iterations to about 50. Maximum iterations denotes the number of calculations at each frame. A value of 50 will lead to faster calculations but less accurate simulations, and a higher value leads to slower simulations but it leads to more accurate simulations. So for pre-visualization, I'm going to set a value of 50, and let's come down, and we'll select the vorticity to about 0.8. Vorticity denotes the amount of curliness and twisting in the flames. A value of 0.8 will get a more twisted and curly look inside the flames that looks much like campfire. So I'm going to set a value of 0.8, and as for turbulence, I'm going to set it about 0.1 for X, Y, and Z turbulence, and the turbulence noise seems pretty good. As for the detail, for pre-visualization, we'll set a value of 1, and during our final simulation, we'll be setting a value of 5 for getting some complex turbulence going on inside the grid. And let's come down and let's see how the simulation looks like right now. Okay, as you can see, the simulation is the flames are a bit too short, so let's increase the burn rate, uh, or rather let's decrease the burn rate so that the flames die out much more slowly. I'm going to set a value of 20 and a burn rate variation of 1 so that we get some nice randomness, and let's simulate it. And as you can see, some of the flames are getting clipped off at the top of the bounding box. Let's see how we can increase the bounding box size. Well, the natural way for users to increase the bounding box size is by scaling it in the z direction. But what happens when we scale it in the z direction is you can see over here that the small cube gets elongated in the z direction. This cube is known as a voxel, and it is like a basic pixel for the grid, and this has to remain perfectly cuboid in shape. But right now, as you can see, it is a bit elongated in the z direction, and this leads to some unrealistic simulations, like we are getting some nice unrealistic elongations in the z direction, which does not lead to some realistic simulations. So the best method to increase the z axis increase the scale of the bounding box in z direction is by using the height value in the FumeFX general parameters. So by doing that, you can see that uh, we can increase the height of the simulation without modifying the shape of the voxel. So that will lead to some nice simulations. And I think we can also increase the width of the FumeFX grid and move just a bit over here like that. And let's now go into the FumeFX simulation dialog, and let's come down, and we're going to enable fire create smoke so that as the fire dies out, it generates smoke, and that's the effect what we want. And I'm going to set the smoke density to about a value of 1, and not going to use any extra detail like fluid mapping or wavelet turbulence right now. Later on, I'll be showing you what wavelet turbulence is, and how we can increase the detail of the simulation by using wavelet turbulence. Right now, let's go into the general parameters, and we'll see what the sensitivity value does for our simulations. Uh, as you can see that we've enabled adaptive for our grid parameters. What that does is at the start of the simulation, it does not occupy the entire grid. Instead, it just adaptively occupies which space the flame is going to be using, and that leads to some lesser memory space requirements for the FumeFX simulation. So right now let's simulate and see what our adaptive grid looks like. And as you can see, as the flame size grows larger, the adaptive grid size also grows larger. But as you can see, only a small portion of the grid is being used right now, but the entire grid has been occupied by the adaptive grid. So to reduce this property, we can increase the sensitivity of the grid, or we can increase the sensitivity. That way the adaptive grid clings on to the shape of the fume a bit more tighter, so that we can get some nice uh, uh, good memory saving. So let's simulate now and see what we get. And you can see that the adaptive grid clicks onto the smoke a bit much better. That's the effect what we want. Let's stop the simulation, and right now I'm going to add a wind modifier, wind helper, and let's rotate it onto the so that it faces the right hand side like that. And Let's move it out of the grid, and let's tweak the parameters of the wind. For the wind turbulence, I'm going to give it a value of say 0.5, and the frequency is going to be about 5, and I'm going to reduce the scale a bit so that the turbulence fields are a bit more smaller. So I'm going to set a value of 0.7. And as for the strength of the wind parameter, I'm going to set a noise float value so that the flames just move back and forth, giving some nice realistic campfires. Because in a real campfire situation, the ambient wind causes the flame to dance and oscillate back and forth. So that's the effect what we are going to achieve. For that, let's go into the curve editor, and let's come down to the object properties, and right click on the strength and assign a noise float controller, and I'm going to set the strength to be greater than 0, and the strength value of about 3, and I'm gonna decrease the frequency so that the variation over time is a bit smaller. And let's see what we got right now. The maximum value is about 2.5, so I'm going to increase it to something like 4. That will do good, and let's see what this value looks like. Let's close the track view and play back our simulation. Before that, we have to connect the wind into the FumeFX simulation. For that, let's go into the object source dialog, and let's pick the wind. And right now the wind is attached to the FumeFX simulation, and let's simulate it. Right now there is not much of variation in the fume, so let's increase the strength. Let's go to the graph editor. The curve editor, and let's increase the strength to 5. And I'm also going to increase the frequency just a bit, and see how that looks. Okay, that looks a bit perfect. Let's close it and run our simulation again. This looks better. As for the coloring of the fire and smoke, I'm going to do that after I finish the final simulation. That way we can get some nice outputs from the FumeFX preview window. And now let's go into the simulation parameters, and let's see if we have missed out something. Nothing. So right now let's take a look at what wavelet turbulence does for us. For that, you have to go to the exporting channels and export extra details. Yeah, for that, let's go into the simulation, and let's enable uh, what we have over here as wavelet turbulence, and let's go into the wavelet turbulence tab, and right now we have some options over here that says grid detail scale. The grid detail scale decides the amount of detail that's going to get added into the FumeFX simulation. Value of 2 adds about twice the detail, and value of 3 increases the detail. You can see that the sim size also increases as we increase the grid detail scale, and this is also directly proportional to the spacing value that we have over here. So the lesser the spacing value, the more detail we get over here. A value of 3 would do good for us. And you can see that there are 3 separate fields for fire, smoke and fuel. What this does is the strength decides the amount of detail that's going to get added into the fire channel, and the threshold decides the spacing between where each detail is going to get added. So the lesser the threshold, the lesser the detail that's going to get added, or the greater the strength, the more uh, sharper the details that are going to get added. So a value of 3 would do good for the strength, and we leave the value of threshold at 1. And I'm going to set the strength of the smoke to about 4, because the smoke needs to have a bit higher resolution. And yeah, that's it. Before simulating the final simulation, let's one thing you need to do is increase the range of the output to something like 500, and we'll also increase the playback range to 500. And let's increase the spacing of the simulation at about 1, and generally a size of about 200 by 200 by 200 is perfect for simulation of this scale. Right now a value of spacing of 1 leads to 178 by 114 by 125, which is fairly good for our setup. uh, so let's simulate this scene, and see what the final effect is before we apply the colors to the flame and the smoke. I'm going to pause this video right now and continue after the simulation. And one thing I forgot to do before starting the final simulation is increase the maximum iterations back to 200, and also uh, we'll set the expansion to about 0.6, because expansion decides the amount of pressure that's inside the fire. We don't want some high pressure fires, so about 0.6 will do a good value. And let's start the simulation with these values. Okay, so as you can see, I've run the final simulation for some 200 frames, and let's now tweak the color of the flames and the fume. So let's go into the rendering tab, and let's come down, and let's assign a key mode for the color of the fire, and set the interior as black color, like that. And halfway around, let's select another uh, key and assign it as a black color, and you can see the real-time changes over here. Let's decrease the quality just a bit. Okay, and let's assign another darker color over here, and put another key. Okay, and bump up the value of brightness just a bit. Just varying the amount of darkness so that we get some nice detail in the flame. Okay, and let's go into the smoke, and okay, the opacity of the fire can stay at 1, and smoke, let's just darken the smoke color just a bit. Let's assign a key mode, or let's go to the key mode to just give it some variations, the smoke color. And just a problem with the mouse, can't just create a key right over here. And assign its color to something like black. And to bring down the ambient color of the smoke, just going to darken it like that, and also bring down the ambient color just a bit. Okay. And with these settings, I think this is fairly good. Now let's see how we can add some nice ember particles to the FumeFX simulation. First up, let's go into the create panel and create a particle system, a thinking particle system. And let's go into the properties, and I'm going to create a new group and call that as ember group. And I'm also going to create a new master dynamic set. A dynamic set, and call it as pbond. And this is the dynamic set that's going to generate the particles. So let's create a position bond operator, and the particles are going to be generated from the cylinders, and the cylinders are grouped together as a group. So I'm going to select the cylinders as the source. So let's go into the helpers and create a node helper, and I'm also going to get a surface position helper. So let's pick the node. Let's select group 001, and let's pump the node into the node of the surface position helper, and let's get the position of the surface position helper and put it into the position of the particle bond helper. And I'm going to select face for the surface position so that we get some random generation for the surface of the random positions for the surface of the cylinder. And let's play back the simulation. As you can see, the lifetime is a bit too low, so let's go into the particle bond operator and increase the lifetime to about 500. And I'm also going to set a particles per second, and it's going to be 15. And let's come down. Okay. And let's reset the direction to about okay, let the direction be at 1. And I'm going to add the wind node into the thinking particles group. So let's do that by using the bind to space warp tool. And right now, if you go into the thinking particles node and create a new dynamic set, call that as force. And before doing anything into the force dynamic set, let's generate the particles into the ember group. And let's go into the force and bring in the ember group, and go into the dynamics and add a standard force. And you can see that we have got win 001 in the deactive list. Let's activate that and bring in the particle into the standard force, and let's play back the simulation. And as you can see, the wind force is a bit too much for the particles. So let's create a float and give the float value into the multiplier, and let's put a value of 0.01 and play back the simulation. Okay. Let's now enable fire and smoke display in the viewport. Okay, it's already displayed, and as you can see that the ember particles uh, coincide with the fire, but its speed is not coinciding, so it's played back. And as you can see, the ember particles are moving a bit too slowly, so let's increase their speed by going into the position bond and increasing the speed to something like 100 and play it back. Another thing what we can do is we can reduce the variation to about 10 degrees so that there's not much of a direction variation, and we can also increase the multiplier value. Let's first turn on edit on the fly so that we can see some real-time updates, and let's modify the value of the float, and let's play back the simulation. I think the speed can be reduced to something like 80, and we'll also give it a variation of about 25%. Okay, and I'm going to assign a standard shape to the particles. So for that, let's create a new group and call that as shape, and let's bring in the ember particles and also create a standard shape operator, and pump the ember particles into the standard shape operator, and let's create a constant shape, and let's play back the simulation. Let's render it and see what we have getting. And right now the particles are colored in a pink color. I think you can uh, reduce the amount of wind that's influencing the particles just a bit. So let's go into the float, and let's just bring the float value down, and now let's go into the rendering and render it. And as you can see, the particles are colored pink. For that, let's go into the material editor, and okay, let's now go into the thinking particles window, and I'm going to select the shape operator, and assign this material over there, and render and see what we are getting. Right now we are not getting much of a difference because we need to color the particles using vertex colors. So let's assign a vertex color to the diffuse map, come down and select vertex color, and render and see what we are getting. You can see that we are getting some sort of a red, green, and blue color. So for getting some orangish amber particles, what you are going to do is create a standard color operator, and let's expose the vertex color of the standard shape node, and let's pump the color into the vertex color. And as for the color, I'm going to select some uh, orange looking ember particles, and let's render and see what we're getting. And as you can see, now the color is a bit orangish. We're going to add a glow effect to the ember particles to make it look a bit more realistic. For that, or before that, let's see why our smoke is not getting rendered. For that, let's go into the FumeFX dialog, And yeah, the smoke is getting rendered over here, but it's not getting rendered in the final render. That's because smoke needs light to be rendered. So for that, let's create a standard uh, light. Let's create a spotlight. Let's go into the four view mode and create a target spotlight like that, and move it just a bit like that. And let's edit the attributes of the spotlight. Let's turn on shadows and enable ray trace shadows. And let's see what we're getting now. Yeah, before that, you need to add the light into the FumeFX illumination tab. So let's pick the spotlight and give it a render. And right now you're getting the smoke over here. Let's render it and see. And as you can see, mm, the ember particles are appearing black over here. That's because the smoke is hiding them. For that, what we are going to do is we are going to create passes. We are going to export the fire and smoke as a separate pass and the ember particle in a separate pass and composite them together in After Effects. So let's first hide the FumeFX simulation. For that, let's select the FumeFX grid and hide them. And the ember particles are appearing black in color. That's because they are being eliminated from the back side, and so their shadows are being cast on the smoke, and thus they turn up black. So for that, we are going to create a new spotlight. Let's clone this spotlight and move it over to the front side like that. And this spotlight is not going to emit shadows, so shadows will be turned off for the front spotlight, so that we can see the ember particles like that. And we're also going to add glow to the ember particles. Before that, let's adjust the lifetime of the ember particles. So let's go into the thinking particles window, and I'm also going to turn on the smoke. And let's go to the properties, and just let's decrease the lifespan to something like 100. And just come down like that. And that value looks a bit accurate, 37. Let's apply about 35. Okay, and render it and see what we are getting. Okay, I think the lifespan can be a bit more higher to about 38. And right now, let's go ahead and hide our FumeFX simulation. And before that, let's create a camera by clicking on Control C. And we're going to use this camera for exporting the passes. So let's position the camera like that. Let's turn on save frames. and let's move the focal plane or the target near the FumeFX center, and position it just a bit perfectly. And let's go into the rendering tab, and let's come down, adjust the width and height to about 1280 by 720, and let's save the output. Let's create a new folder and call that as ember, and save that as a JPEG, and select the best file size, that is the largest file size, and let's select the range till the end of the FumeFX simulation, that is about 400 frames. I'm going to resimulate the entire simulation again, and let's select the range to 400, and export the ember particles first, and then later on hide the ember particles and expose the FumeFX simulation, and render the FumeFX simulation in a separate path. So after this process, we'll be getting two image lists. One list will be containing the ember particles alone, and another list will be containing the FumeFX simulation alone. We'll be compositing that in After Effects. So let's stop the simulation, stop the process right here, and continue in After Effects. So as you can see over here, I have gone ahead and imported the ember and flame particles, ember and flame simulation passes into the After Effects, and let's create a new composition. First, I'm going to drag the flame into the composition window, and this is going to be the background layer. And next up, we'll drag the ember particle layer onto the flame layer. So the ember is on the top, and right now you can see that the ember particles are hiding the flame. So let's go ahead and set a blending mode. We'll set something like add, and you can see that the ember gets added onto the flame layer. But as you can see right here, there are some flakes that occur due to the linear adding of the color information over here. We can correct that by using a light and blended mode, and that gives us some realistic effects. And next up, let's add some sort of a glow to the ember particles. For that, I'm not going to add a glow effect to it. Instead, I'm going to add a blur effect such that it emulates the glow effect more nicely. So let's go ahead, and I'm going to create a camera lens blur, and I'm going to duplicate the ember layer first, and I'm going to apply the lens blur to this layer, and let's increase the radius, and I'm going to set the shape to decagon so that it resembles more of a circle with 10. It has 10 sides, so the details of the 10 sides don't show up that much, so it appears to be a circle, as you can see over here. And let's increase the blur size just a bit like that. And next up, I'm going to add a Gaussian blur to blur out the edges of this camera blur. So let's go ahead and add a Gaussian blur. Like that, and that gives us some nice blurring effect. And I think you can increase the blur radius to something like 10. Okay, perfect. And the blur effect is not getting added on to the uh, let's say places where the smoke is present. So for that, I'm going to set an add blending mode for this, so that we can see the yellow color. Or let's try normal blending mode, or I'm sorry, overlay. No, let's try a different types of blending mode to see which one matches our needs. Well, I think screen is much better. And let's increase the blurriness just a bit more, like that. And that looks better. And as you can see, the smoke is a bit too dense right here. For that, I'm going to just apply an opacity mask to the flame layer. So let's do that right now. Let's go ahead to layers and add a new mask. And I'm going to go into the mask properties and set the shape to ellipse. And let's tweak the uh, mask just a bit, like that. And let's add some feathering to it, so that the smoke doesn't look as dense, a bit far away from the source of the flame. And let's increase the feathering just a bit more, like that. Okay, so that finishes this tutorial. One thing you can do is go ahead to the curves and adjust the color of the flame to be a bit of a more orangish. But for my effect, I think this will do good. So that's it for the tutorial over here. I've shown you how to create a flame using FumeFX and add ember particles to it using thinking particles. So that's it for the tutorial. And once again, guys, this is Madan for Cgtuts Plus, and see you again in another tutorial.